London, 1851. The Crystal Palace glitters with the finest machines Britain has ever produced, and Joseph Whitworth stands beside his precision measuring tools, devices capable of detecting differences of 1/1,000,000th of an inch. The British establishment examines his revolutionary work, calculates the cost of adopting such precision, and delivers their verdict: unnecessary. Across the Atlantic, American engineers are taking careful notes, and within a single decade, they will use Whitworth's own principles to win every major manufacturing contract Britain assumed was theirs by birthright. The tyranny of good enough. In 1840, if you wanted a rifle in Britain, 12 craftsmen touched it before it left the factory. Each part was filed, fitted, and adjusted by hand until it worked with its neighbors. The barrel was fitted to the receiver, the lock was fitted to the stock, the trigger was fitted to the mechanism. Every rifle was a custom creation, a unique artifact that would never be replicated exactly. This was not a flaw. This was the system. British manufacturing had operated this way for centuries, and it had made Britain the workshop of the world. The craft tradition was sacred. Master craftsmen passed their knowledge to apprentices through years of training. The ability to fit parts together through feel and experience was a valuable skill, a source of pride and livelihood. The economic logic seemed unassailable. Precision tooling was expensive. Skilled fitters could take imprecise parts and make them work. Their labor was cheaper than the capital investment in precision machinery. The math favored the old way, but this system had a hidden cost no one wanted to calculate. When a rifle broke in the field, you could not simply replace the damaged part. The replacement had to be hand-fitted to that specific gun. A soldier with a broken firing pin did not need a new firing pin. He needed a gunsmith. The British Army carried spare rifles, not spare parts, because parts were not interchangeable. The same problem plagued every industry. Steam engines, textile machinery, locomotives, all were assembled through custom fitting. When something broke, you sent the entire machine back to the manufacturer. Downtime was measured in weeks, not hours. During the Napoleonic Wars, British forces maintained vast stockpiles of complete weapons to compensate for the impossibility of field repairs. The logistical burden was immense, but the alternative, investing in precision tooling for interchangeable parts, seemed economically irrational. This was the world Joseph Whitworth was about to challenge. He was not questioning the skill of British craftsmen. He was questioning whether skill should be necessary at all. The British establishment would call this vision unnecessary. The Americans would call it the future. The man who measured millionths. Joseph Whitworth was born in 1803 in Stockport, the son of a schoolteacher. He did not come from manufacturing wealth or aristocratic privilege. He came from the world of practical mechanics, starting his career as an apprentice in a cotton mill. But where others saw machines that worked well enough, Whitworth saw machines that could work better. By his early 20s, he had moved to London and found work with Henry Maudslay, the finest toolmaker in Britain. Maudslay had already revolutionized precision engineering with his screw-cutting lathe and his measuring instruments. But even Maudslay's standards were not enough for Whitworth. He became obsessed with a question that seemed absurd to his contemporaries. How flat is flat? Take a metal surface plate, the foundation for all precision work. Every machinist used them to check the accuracy of their work. You placed your component on the plate, and if light showed between the metal surfaces, you knew you had more filing to do. But how flat was the plate itself? If your reference surface was imperfect, every measurement built upon it would be wrong. Whitworth developed a method so simple, it seemed like a trick. He made 3 surface plates. He ground the first against the second until they matched perfectly. Then he ground the second against the third, then the third against the first. Any high spot on any plate would create a corresponding low spot on another. By rotating through all 3 plates, the errors canceled out. The process was painstaking, requiring days of careful scraping and checking. But when Whitworth finished, he had 3 surfaces that were flat to within 1/1,000,000th of an inch. 1/1,000,000th of an inch. In 1840, this precision was incomprehensible to most engineers. A human hair is approximately 3/1000ths of an inch thick. Whitworth was measuring to accuracies 3,000 times finer than that. His contemporaries questioned whether such precision was even meaningful. At that scale, temperature changes and air pressure variations affected measurements. Was Whitworth measuring reality, or chasing ghosts. He proved the skeptics wrong by building measuring devices that could detect these microscopic differences consistently. His bench micrometer used a finely threaded screw to convert rotational motion into linear displacement. One full turn of the handle moved the measuring point by a precise amount. By dividing the rotation into smaller and smaller increments, Whitworth created an instrument that could measure to millionths. The process required absolute control over every variable. The temperature in Whitworth's workshop was regulated carefully. The measuring devices were designed to minimize the effect of the operator's body heat. The reference surfaces were cleaned obsessively to remove any particle that might introduce error. Whitworth transformed precision measurement from an art into a science. But precision measurement was only half the solution. Whitworth understood that accurate measurement was useless unless you could manufacture to those standards consistently. He developed a series of machine tools, lathes, planers, and shapers that could hold tolerances previously thought impossible. These machines used his precision measuring devices to calibrate themselves, creating a self-referencing system where accuracy bred more accuracy. The economic implications were revolutionary. With Whitworth's tools, an apprentice could produce parts that matched the specifications exactly. The skilled fitter, the craftsman who spent years learning to hand-fit components, was no longer essential. The precision was built into the machine, not the man. Whitworth took his innovations to the British industrial establishment. He published papers detailing his methods. He demonstrated his measuring devices at exhibitions. He showed factory owners how precision tooling could reduce costs, improve quality, and enable true interchangeability. The response was polite interest, followed by calculated rejection. His tools were impressive, certainly, but also unnecessary. The standard that Britain rejected. The chaos was invisible until you tried to connect anything to anything else. Every workshop in Britain used screws. Every factory had threaded fasteners, but there was no standard. One manufacturer used 55 degrees for the thread angle. Another used 47. The pitch varied randomly. The depth of the thread was a matter of personal preference. This meant that a bolt made in Manchester would not fit a nut made in Birmingham. A steam engine manufactured in Leeds needed custom fasteners that could not be sourced anywhere else. Maintenance required keeping vast inventories of proprietary parts. The inefficiency was staggering, but it was familiar inefficiency. It was how things had always been done. In 1841, Whitworth proposed a solution so obvious it seemed revolutionary. Standardize the thread form, pick one angle, one pitch progression, one set of dimensions, and make every manufacturer in Britain use it. He had done the mathematical analysis. He had tested different thread forms for strength and ease of manufacturing. He presented his findings to the Institution of Civil Engineers. The Whitworth thread used a 55-degree angle and a specific pitch for each diameter. The thread depth and the radius of the root and crest were precisely defined. Any component made to these specifications would fit any other component made to the same standard. It was precision democracy. A bolt made in Glasgow would screw perfectly into a nut made in London. The engineering community recognized the elegance of the system. The Institution of Civil Engineers endorsed it. The British Association for the Advancement of Science supported it. Whitworth had the backing of the technical establishment. What he did not have was the cooperation of the manufacturers. The workshop owners looked at Whitworth's proposal and saw a threat. Adopting his standard meant replacing tooling. It meant retraining workers. It meant abandoning proprietary thread forms that locked customers into buying replacement parts from the original manufacturer. This last point was crucial. The lack of standardization was not a bug in the British manufacturing system. It was a feature. A factory that made steam engines using its own unique thread pattern had a captive market for spare parts. Customers could not source components from competitors. This created guaranteed revenue streams and customer dependency. Whitworth's standard threatened to commoditize what had been profitable monopolies. The resistance took the form of technical objections dressed up as practical concerns. Some argued that the 55-degree angle was not optimal for all applications. Others claimed that the pitch progression did not suit their specific needs. Still others insisted that their existing thread forms were perfectly adequate, and that changing would confuse workers and introduce errors. Beneath these objections lay economic calculation. The manufacturers were weighing the cost of adoption against the cost of resistance. Adoption required immediate capital expenditure with uncertain long-term returns. Resistance cost nothing in the short term. The decision was obvious. The British government declined to mandate the standard. Without regulatory force, adoption remained voluntary. Some progressive manufacturers embraced Whitworth's system. The railroad industry, facing the chaos of incompatible components across different lines, adopted it widely. But large sectors of British manufacturing continued with their proprietary chaos. The Whitworth standard became a curiosity, a technically superior solution that the market rejected. Engineers praised it in papers while workshops ignored it in practice. Whitworth's precision measuring tools faced the same fate. They were displayed at exhibitions as examples of British engineering excellence. Then they were purchased primarily by foreign buyers. The 1851 Great Exhibition at the Crystal Palace was supposed to be Britain's moment of industrial triumph. Whitworth displayed his precision tools alongside his standardized thread system. The British establishment admired the craftsmanship. Then they returned to their factories and continued making parts the old way. But in the American section of the exhibition, manufacturers from Connecticut and Massachusetts were taking careful notes. They saw something the British had missed. Whitworth's innovations were not just impressive demonstrations. They were the key to mass production. America was watching. The Americans arrived at the Crystal Palace with a chip on their shoulder and a hunger in their gut. They were the former colony, the industrial upstart, the nation whose manufactured goods were dismissed as crude imitations of European craftsmanship. They watched the British exhibition with the careful attention of students planning to surpass their teachers. Samuel Colt was there, demonstrating his revolvers. Robbins and Lawrence displayed their rifle machinery. These manufacturers had already stumbled upon the concept that would transform American industry. They called it the American system of manufacturing, and it was built on a principle the British found distasteful: replace skill with precision. The American gunmakers had a problem the British did not face. Labor was expensive in the United States. Skilled craftsmen could find high-paying work in a rapidly expanding economy. A gun manufacturer in Connecticut could not rely on the endless supply of trained apprentices that sustained British workshops. American factories needed to produce weapons with fewer skilled workers. The solution was to make the machines do the precision work. Whitworth's tools offered exactly what American manufacturers needed. His measuring devices could verify that parts met specifications without requiring the judgment of a master craftsman. His precision tooling could manufacture components to tolerances that eliminated the need for hand fitting. His standard thread system would enable true interchangeability. The contrast in reception was stark. British manufacturers looked at Whitworth's innovations and calculated the cost of disrupting their existing systems. American manufacturers looked at the same tools and calculated the cost of not adopting them. The Americans were building new factories in a new country, with an acute shortage of skilled labor. They had no legacy systems to protect. They had every incentive to embrace precision. Robbins and Lawrence returned from the Crystal Palace and immediately began purchasing Whitworth measuring instruments. The Springfield Armory, the U.S. government's primary weapons facility, sent engineers to study Whitworth's methods. By 1853, American manufacturers were producing rifles with fully interchangeable parts using precision tooling based on Whitworth's principles. The British Army noticed. More specifically, they noticed during the Crimean War when their logistics system collapsed under the impossibility of field repairs. British soldiers carried rifles that could not be repaired with spare parts. When a lock mechanism broke, the entire rifle became useless. The Army had to ship damaged weapons back to England for refitting or replacement. Meanwhile, the British military was purchasing rifles from American contractors. The Enfield rifle, designed in Britain, was being manufactured by Robbins and Lawrence in Vermont with fully interchangeable parts. An armorer could replace any component without fitting or adjustment. The rifles shipped with crates of spare parts that could be installed by soldiers in the field. The humiliation was complete when British ordnance officials visited the Robbins and Lawrence factory and realized that American manufacturers were using Whitworth's precision standards, while British manufacturers still relied on hand fitting. The tools Britain had called unnecessary were enabling America to fulfill British military contracts more efficiently than British factories could. The irony deepened. Whitworth himself was contracted to produce rifles for the British Army. His factory could produce weapons with interchangeable parts because he used his own precision tooling, but the broader British manufacturing base could not match his standards. When the government tried to source components from multiple suppliers to increase production, the parts would not fit together. Each factory was making to its own interpretation of the specifications. The American system was proving superior, not because American engineers were more talented, but because they had embraced the precision standards British engineers had developed and British manufacturers had rejected. Samuel Colt's Hartford factory became a pilgrimage site for European industrialists, trying to understand American manufacturing efficiency. What they found was Whitworth's principles implemented at scale. The gauges were Whitworth-derived, the measuring instruments were Whitworth-inspired, the thread standards were Whitworth's 55-degree angle. The Americans had taken British innovation, stripped away the craft tradition, and built an industrial system that prioritized precision over skill. By 1855, the Springfield Armory was producing rifles at a rate British factories could not match, with quality British inspectors grudgingly admitted was superior, using methods British manufacturers had dismissed as too expensive. The cost per rifle was lower, the reliability was higher, the maintenance was simpler. Every metric favored precision. British military contractors faced a brutal choice: invest in Whitworth's precision tooling or watch American manufacturers take their contracts. Some upgraded, many did not. They assumed the advantage was temporary, that British craftsmanship would ultimately prevail over American mass production. They were wrong. The Americans were not just adopting Whitworth's tools, they were building an entire industrial philosophy around precision as the foundation of efficiency. The sewing machine, the typewriter, the bicycle, and eventually the automobile, all would emerge from American factories using precision manufacturing methods British workshops had rejected. The contract wars. The Crimean War exposed the lie British manufacturers had been telling themselves for decades. Quality through craftsmanship was losing to quality through precision, and the battlefield was becoming a showroom for American manufacturing superiority. In 1854, the British Army needed rifles. They needed them immediately, and they needed them in quantities that traditional British workshops could not supply. The Enfield pattern rifle had been adopted as the new standard. The design was solid, the problem was manufacturing it. The Royal Small Arms Factory at Enfield could produce approximately 20,000 rifles per year using traditional methods. The war required 10 times that number. The government turned to private contractors, issuing specifications and expecting British manufacturers to scale up production. The results were catastrophic. Different contractors interpreted the specifications differently. Parts made by one factory would not fit rifles assembled by another. The tolerance stack-up meant that even parts made to the nominal dimensions would not assemble properly. Inspectors rejected entire batches. The rifles that did pass inspection often failed in the field because the hand-fitted components could not withstand battlefield conditions. The British Army was fighting a war with a logistics system designed for craft production. When rifles broke, they became useless. The supply chain could not handle the volume of repairs. Soldiers wrote home describing weapons that jammed, misfired, or simply fell apart under use. The manufacturing crisis was becoming a military crisis. Meanwhile, American contractors were offering a solution. Robbins and Lawrence proposed to manufacture Enfield rifles using precision tooling with fully interchangeable parts. The British government, desperate for functional weapons, placed an order for 25,000 rifles. The contract was humiliating. Britain was paying American manufacturers to build British-designed weapons because British factories could not meet the specifications. The American rifles arrived and performed flawlessly. Every part was interchangeable. Field repairs were simple. The manufacturing quality was so consistent that British inspectors initially suspected the Americans were somehow cheating, that such precision could not be achieved in production volumes. British ordnance officials visited the Robbins and Lawrence factory in Vermont to investigate. What they found shattered every assumption about manufacturing economics. The factory was achieving precision not through skilled craftsmen, but through precision machinery. The workers were not master gunsmiths. They were machine operators. The tools were doing the precision work. The cost per rifle was lower than British manufacturers could achieve. the production rate was higher. The reject rate was negligible. Every metric demonstrated the superiority of precision, tooling over craft tradition. The British observers returned home and reported that American manufacturing methods represented the future of industrial production. The British gun-making establishment responded with denial and resentment. They argued that American methods lacked the artistry of British craftsmanship. They insisted that hand-fitted rifles were superior to mass-produced weapons. They claimed that precision tooling was a temporary advantage that British workshops would soon match. But the contracts told a different story. American manufacturers secured orders for Enfield rifles, Colt revolvers, and eventually artillery components. British manufacturers watched their market share erode as customers, including their own government, chose American precision over British craftsmanship. The economic reversal was stunning. In 1830, Britain dominated global trade in manufactured goods. By 1860, American manufacturers were winning contracts for products designed in Britain, built with principles developed by British engineers, sold to British customers. The only component missing was British manufacturing. Whitworth himself was caught in the middle of this reversal. His factory could produce to the precision standards that American manufacturers had adopted. But he was one workshop in an industrial ecosystem that refused to change. When he bid on military contracts, he competed against American factories that had built their entire operations around his principles, while British competitors still relied on methods his innovations had made obsolete. The final insult came when the British government commissioned a report on American manufacturing methods. The report, published in 1854, praised the American system and recommended that British factories adopt precision tooling, standardized measurements, and interchangeable parts. The recommendations were ignored by most British manufacturers. They had invested too much in the craft tradition to abandon it, based on some report about American methods. But the Americans were not standing still. They were refining Whitworth's principles, developing new measuring instruments, and building machine tools that achieved even greater precision. The gap was widening. Every year, American factories became more efficient, while British workshops continued using methods that had been adequate in 1800 but were failing in 1860. The price of pride. The industrial leadership Britain lost in the 1860s never returned. The craft tradition that had made Britain the workshop of the world became the anchor that dragged British manufacturing into decline. The Americans had learned the lesson British manufacturers refused to accept. Precision was not a luxury. It was the foundation of modern industry. By 1870, the divergence was obvious to anyone willing to see it. American factories were producing sewing machines, typewriters, and agricultural equipment with fully interchangeable parts. British manufacturers were still relying on skilled fitters to assemble products one at a time. The cost difference was devastating. A Singer sewing machine made in America cost less than a British-made equivalent and worked better. The American machine could be repaired anywhere with standard parts. The British machine required a craftsman to fit replacement components. Customers voted with their purchases. British sewing machine manufacturers went bankrupt. The bicycle industry repeated the pattern. American manufacturers like Pope and Schwinn built bicycles using precision tooling and interchangeable parts. British manufacturers relied on craft methods. The American bicycles were cheaper, more reliable, and easier to maintain. British bicycle exports collapsed. The machine tool industry, the foundation of all manufacturing, showed the most dramatic reversal. In 1840, British machine tools were the finest in the world. By 1890, American machine tools dominated global markets. Companies like Brown and Sharp, Cincinnati Milling Machine, and Pratt & Whitney built their businesses on the precision standards Whitworth had developed and British manufacturers had rejected. The economic cost was staggering. Britain's share of global manufacturing output declined from 40% in 1870 to 20% by 1900. The Americans surged past, reaching 30% by 1900. The Germans, who had also embraced precision manufacturing, climbed to 16%. Britain was being overtaken by nations that had learned the lessons British manufacturers refused to teach themselves. The human cost was equally severe. Skilled craftsmen who had spent years learning hand-fitting techniques found their expertise worthless in the new industrial economy. The workshops that had sustained generations of families closed. The apprenticeship system that had transmitted craft knowledge collapsed. The very tradition British manufacturers had protected so fiercely was destroyed by their refusal to adapt. Whitworth died in 1887, wealthy but frustrated. His precision standards had transformed manufacturing everywhere, except in his home country. The British Standards Institution would eventually adopt his thread system in 1906, 65 years after he first proposed it. By then, Britain was importing machine tools from America and Germany because British manufacturers could not match the precision standards their own countrymen had invented. The First World War exposed the full extent of British industrial decline. Britain entered the war dependent on American manufacturers for artillery shells, rifle components, and machine tools. The nation that had ruled global manufacturing could not supply its own military. British factories, still structured around craft production, could not scale to wartime demand. The interwar years brought no recovery. American mass production methods, evolved from Whitworth's precision principles, created affordable automobiles, radios, and household appliances. British manufacturers remained trapped in low-volume, high-cost production. The companies that did survive often did so by licensing American technology or importing American machine tools. The Second World War completed the reversal. Britain became dependent on American manufacturing for everything from aircraft engines to tank components. Lend-Lease was not just military aid. It was an acknowledgement that British industry could no longer supply its own defense needs. The precision manufacturing base that could have been built on Whitworth's innovations existed in America, not Britain. Post-war recovery efforts could not reverse the decline. British attempts to compete with American mass production failed repeatedly. The automotive industry struggled until foreign manufacturers bought the brands. The machine tool industry vanished almost entirely. By the late 20th century, Britain had transformed from an industrial powerhouse into a service economy, importing manufactured goods from nations that had embraced the precision manufacturing revolution Britain had pioneered and rejected. The tragedy was not that Whitworth's innovations were flawed. The tragedy was that they worked exactly as promised, but only for those willing to abandon tradition in favor of efficiency. The British manufacturers who called precision tooling unnecessary paid for that judgment with their livelihoods, their industries, and their nation's economic leadership. The Americans who embraced Whitworth's principles did not just win contracts. They built the industrial foundation of the 20th century. The mass production that enabled affordable automobiles, household appliances, and consumer electronics was built on precision manufacturing. The supply chains that span the globe depend on interchangeable parts and standardized measurements. The modern world runs on the principles Joseph Whitworth developed and Britain rejected. The invisible victory: walk into any hardware store today and pick up a bolt. The thread form is likely ISO metric, but the principle is pure Whitworth. Standardized dimensions, precise angles, guaranteed interchangeability. The bolt from one manufacturer will thread perfectly into a nut from another. This convenience, so mundane we never notice it, required fighting a century-long war against the craft tradition. Look at your smartphone. The components are manufactured in a dozen countries, shipped to assembly facilities, and combined into a functioning device. This is possible only because precision manufacturing enables parts made in separate factories to fit together perfectly. The tolerance stack-up that defeated British rifle contractors in the Crimean War has been solved so thoroughly that we assemble complex electronics with zero custom fitting. The measuring instruments in modern machine shops can detect variations of nanometers. They are descendants of Whitworth's bench micrometer, refined through generations, but built on the same principle. Convert the rotation of a precision screw into linear displacement, then measure that displacement to ever finer degrees. The pursuit of precision that British manufacturers called unnecessary became the foundation of every advanced industry. The aerospace industry depends entirely on precision manufacturing. Aircraft engines contain components manufactured to tolerances of microns, assembled without hand fitting, maintained with interchangeable parts. A turbine blade manufactured in Ohio must fit perfectly into an engine assembled in France. This is Whitworth's dream realized at a scale and precision he could not have imagined. The medical device industry builds life-saving equipment using precision manufacturing. Artificial joints, surgical instruments, diagnostic machines all depend on components that meet exact specifications. The quality control systems that verify these standards trace directly to Whitworth's insight that you must be able to measure precision before you can manufacture it. The automotive industry produces millions of vehicles annually, each one assembled from thousands of precisely manufactured components. The interchangeability that enables this scale of production was thought impossible by British craftsmen in 1840. Today, a replacement part for a vehicle manufactured in Japan fits perfectly into an identical model assembled in Mexico. This is the economic victory of precision over craft. But the deepest legacy is not in the products, it is in the mindset. Modern manufacturing assumes that precision can be achieved, that standards can be maintained, that interchangeability is possible. These assumptions, now so obvious they seem natural, were revolutionary in 1840. They required proving that machines could be more precise than human hands, that standards could improve efficiency rather than constraining creativity, that mass production could achieve quality that craft methods could not match. The British manufacturers who rejected Whitworth's innovations believed they were protecting their competitive advantage. They thought their skilled craftsmen, their accumulated expertise, their established methods were impregnable assets. They learned too late that in times of industrial transformation, the greatest risk is not adopting new technology too quickly. The greatest risk is rejecting it too slowly. Whitworth's story is not really about thread standards or measuring instruments. It is about the economic cost of saying no to innovation. Britain called his precision tools unnecessary and lost a century of industrial leadership. America embraced those same tools and built an economic empire. The machines were identical. The difference was the willingness to change. Today we live in a world where precision is assumed, where interchangeability is expected, where standardization enables global manufacturing. We inherit this world not from the British craftsmen who protected tradition, but from the American manufacturers who embraced innovation. We benefit not from the wisdom of the establishment, but from the vision of the outsiders who refused to accept that good enough was adequate. The next time you thread a bolt into a nut and it fits perfectly, remember that this simple convenience required overthrowing the entire craft tradition of industrial production. Remember that the British establishment looked at the tools that enabled this precision and called them unnecessary. And remember that sometimes the most expensive word in business is no.